Hello, and welcome to my Algebra 1 review series. This video covers Chapter 9, Section 4, titled Multiplying Special Cases. By the end of this video, you will have reviewed past lessons describing the methods of multiplying special cases, which employ using the distributive property and multiplying using FOIL. This is all necessary to find the square of a binomial and find the difference of squares, do some mental math, and a real-world problem. If you would like me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to the channel if you find this video to be helpful. Thank you. Okay, so objective 1, finding the square of a binomial. You can find the square of a plus b, or squared here, a plus b squared, using the methods you learned in a previous lesson. The common method is FOIL, first, outer, inner, last, which states, the quantity a plus b times the quantity a plus b is equal to a squared plus ab plus ba plus b squared. That's using FOIL. And then when you simplify it, you get a squared plus 2ab, because the a and the b can be switched, commutative property, and b squared. Okay, so the expressions a minus b squared and a plus b squared, those binomials, are squares of binomials. To square a binomial, you can use FOIL or the following rule, and then the rule is in this box here. So what's the rule? The square of a binomial. So the quantity a plus b squared is equal to a squared plus, it's important, this is a plus b now. A plus b squared is equal to a squared plus 2ab plus b squared. Now, the other option you have here is a minus b squared. And with the minus, you'll see that it's a squared minus 2ab plus b squared. So all you have to remember then is that when your binomial has a plus in here, and there's my pen, it quit working, has a plus in here, that you've got a plus right here on the 2ab. And if there's a minus in here, it's a minus 2ab. So the square of a binomial is the square of the first term plus twice the product of the two terms. Twice the product of the two terms. A and b are the terms. So it's 2ab plus the square of the last term. Okay, example 1, squaring a binomial. So let's do it. So it says find x plus 7, the quantity, x plus 7 squared. Okay, the binomial, x plus 7 squared. So what is it? As you see here, I'm going to rewrite the binomial here, and the squared binomial. And then I can immediately start converting it. I know the first term, x, it's x squared. I know the last term, 7, is 7 squared. In the middle, and since there's a plus right here between the x and the y, I know that there's a plus right here between the two of these two, right here. So it's a plus 7x. X and 7 are the terms. So you multiply them, 7x, and take two of them. Okay, so then once we do this, we can say x squared, bring it down here, and 2 times 7 is 14, right here, 14x. And then 7 squared is 49. How about this one? The binomial 4k minus 3 squared. So we've got 4k minus 3 squared. So we've got 4k squared. At the end, I've got 3 squared. And in the middle, I've got minus. Here's the minus. I've got minus 2 times 3, which is this 3 here, times 4k, which is the 4k right here. Minus 2 times 3 times 4k. And when you multiply that out, you're going to get 4 times 3 is 12 times 2 is 24. And it's negative. So the answer, and here we have to take the 4 in squared and the k in squared. 16k squared minus 24k plus 9. 3 squared is 9. Okay, so here we are, example 1, check your understanding. Find each square. So work these on your own. You've seen how to do it. It's pretty easy. The first term squared, the last term squared. Then you look at the plus or minus, decide if it's minus 2 times the two terms, t, or the first and second term, or if it's a negative 2 times the first and second term. When you get back, we'll go ahead and do them. Okay, now that you've returned from doing these yourselves, let's go over them. So the first one in A here, we have t plus 6 squared, right? The quantity t plus 6 squared. So we take the first term, t, in the parentheses. I like to use parentheses around these terms. You'll see why in a minute. Squared. And the final term is the 6 squared. And then in the center, it's plus, because up here is a plus. Plus 2 times 6 times t. Multiplying these two terms, t times 6 times 2. And when you simplify it, you get t squared plus 12t. 2 times 6 is 12. Plus 36. Let's do this one. It's another plus. So we're going to say the quantity 5y plus 1 squared. Here it is, 5y plus 1 squared. I put parentheses around the 5y squared. Plus, here's the plus here, plus 2 times 5y. 5y, you don't have to worry about the 1. You're going to multiply it as just 1. So it's 2 times 5y. We have to get the 5y in here. You have to have the y. So 2 times 5y. And then at the end, 1 squared. So 5y squared is 25y squared. Plus 2 times 5 is 10y. Plus 1. C. The quantity 7m minus 2p squared. Well, here it is. It's a little tougher, but nothing too tough. We're going to take the first term, 7m, right here, and square it with the parentheses around the entire term. And at the end, it's plus 2p squared. Here's the 2p squared. Okay? You don't have to worry at all about the negative sign for the plus on the beginning, at the end. It's only in the middle where you worry about that negative sign. But that's negative right there, because this is negative. This is negative. And then it's 2 times 7m times 2p. So that would be negative 2 times 7 times 2, right? So when you come down here, it's going to be negative 28 mp. The first term is 7 squared, which is 49 m squared. And the last term is 2 squared, which is 4p squared. So it's 49 m squared minus 28 mp plus 4p squared. Let's do D. So the quantity 9c minus 8 squared. So I take the parentheses right here, and I always put these in parentheses, or I try to remember to. 9c squared. Then at the end, it's 8 squared right here. And then it's minus, because we have a negative, minus 2 9c times 8. 9c times 8. Okay? And the answer to that then is what? 9 squared is 81. C squared is c squared. The 8 squared is 64 at the end. The middle is 144. Well, the easy way to get that is 9 times 8 is 72. Times 2 is 144. So it's negative 144 times the c. We can't forget that c. Okay. Okay, so here we are at example 2. It's a real world problem. And I can tell you it's very interesting. It took me a little while to figure out exactly what we were doing on these two slides, this one and the next slide. And I want you to know that it's going to be difficult. So I'm going to try to explain it, and we'll go through it together, okay? I'm not going to have you work on your own. I'm just going to work it with you because I think it's just worth talking about it as we're doing it. But it says the Punnett square at the right models the possible combinations of genes that parents who both carry one gene of a trait to have that trait become dominant in their offspring. Okay, hopefully in science or biology you've talked about gene a little bit of gene therapy, or the understanding of how genes work in our cells. Okay, so since what they're saying here then is since YY, right here, YY in the chart is 1/4 of the outcomes, right here. There are 4 outcomes, DD, DY, DY again, and YY. So this is dominant. They have the dominant gene and the non-dominant gene. Actually, this is about Doberman, not Doberman. It's called about Labrador Retrievers. So there's dark Labradors. I think that includes the black and the browns. And then there's the yellow labs. The Y is for yellow and the D is for dark. So if any Labrador Retriever has a D gene, one of the D genes, either he can get the dark gene from his father or from his mother, he's going to have a dark coat. The yellow lab has to have a yellow, this Y gene, one from each of its parents, and then it'll be yellow. Okay, so if any one combination of these 3, the DD for dark and dark from the mother and the father, and then a dark and a yellow from maybe the dark from the father and yellow from the mother, and or dark from the mother and yellow from the father. Those are all dark genes. Those are all going to make dominant dark dogs. And then we have the yellows, which would be like we was talking about. There's 1/4 can be yellow, and 3/4 of them here give you dark. So that's kind of what they're trying to talk about here. So they're going to say 1/4 of the outcomes, the possibility for that offspring to have both genes, and thus have a gene become dominant as 1/4 of the time. Okay, that's 1/4 of the time. This gene right here, the YY, is going to be dominant because it's the 2 genes together. Anytime those 2 Ys come together, the dog will be yellow. So you can model the probabilities found in the Punnett chart with the following expression. We've been looking at these expressions, which is 1/2 D, 1/2 dark, plus 1/2 yellow squared. That's the term, okay? This is a binomial squared. And when you do that, you're going to get 1/2 D squared for the first term. For the last term, you're going to get 1/2 Y squared. And then for the middle term, it's going to be plus, because it's a plus here, it's going to be plus 2 times 1/2 D times 1/2 Y. And mathematically, what you'll end up with is this is going to be 1/4 squared, 1/2 squared is 1/4, and D squared. Over in the backside, 1/2 squared is 1/4, Y squared. Okay? In the middle terms, you've got D times 1/2 D, 2 times 1/2 D times 1/2 Y. Well, if we do that, we're going to find out that the 2 on this, say 2 times 1/2 is going to give us 1. So it's going to be 1/2 dy is what you're going to end up with. 1/2 dy. So that's basically the math. You're going to have the 1/4 d squared, which is 2 d's, 1/4 of the time. This is what it's telling you. Look, 1/4 of the time, you're going to have d times d. Here's d times d. And it's 1 of the 4. 1 of 4. 1/4 of the time, you're going to get d times d. 1/4. And 1/4 of the time, you're going to get yellow squared. Yellow times yellow. 1/4 of the time. Here's 3 non-yellow yellows. Here's a yellow yellow. 1 out of 4. 1/4. Okay? And there's half a chance, 50-50, that the offspring will inherit both genes, which is the dog could have a yellow and a dark gene. Could get one from the father as dark and one from the mother as yellow, and or the other, or vice versa. And that is half the time. So as you see it, 2 right here, 2 out of 4 is 1/2. So that kind of, this equation kind of matches and mimics this little box. Okay? And this is the same probability shown in the Punnett chart. So this is exactly what we have. A quarter of it is two D's, a quarter of the time it's two Y's, and a half the time it's a D and a Y. That's what they're trying to say here. I hope that you understand it. It's not as important that you understand the genetics about it as much as maybe the quarters and the halves that we're talking about, and the two D's and the two Y's. That's hopefully you can at least get that part. It's a little difficult. I had to read it a couple of times here to be able to understand it and hopefully explain it to you. So now let's look at a problem. So now we're going to check your understanding, but I'm not going to have you do it on your own. We're just going to do it together, okay? So, and right away, the problem is different than what they gave us. It's not a quarter and a quarter or a half and a half. It's when you play a game with two cubes, numbered cubes, right? 1, 2, 3, 4, 5, 6. You can find the probabilities of squaring a binomial, and we're going to talk about it. So let A represent the probability of rolling a 1 or a 2. So if you roll a 1 or a 2, that's an A type of roll. You roll it, you get a 1, that's an A roll. If you roll it and get a 2, it's an A type roll. And or the other cases, we'll let B represent rolling a 3, 4, 5, or 6. If you roll a 4, you rolled a B roll. So you get it that they labeled letters on rolls that had those numbers on them. So you got A rolls and B rolls. And so if you look at the probability here, you're going to get, where'd my pencil go again? Probability is A is going to be 1/3 because you're going to get a 1 or a 2 out of 6. So 2/6 is the same as 1/3. And the probability of B is 2/3 because it's 3, 4, 5, 6. There's 4 terms over 6. 4/6 is 2/3. So that's the lead in here. So given that information, we're going to try and find and work this equation from the previous slide. So it says find 1/3 A plus 2/3 B. So you get the picture. This is all the rolls, the A rolls and the B rolls. And you're going to get an A roll 1/3 of the time, right here. And you're going to get a B roll 2/3 of the time. And then once you do that, plus the 2, you're going to square it. So let's square it. Let's do that. So we're going to get, here's the equation written again. We're going to get 1/3 A, right here, 1/3 A, that's our first term, squared, plus 2 1/3 A, 2/3 B, plus 2/3 B squared. Okay? So now we got that. We've got it to that point. We're going to go over the middle term and try to understand the math on it. So like I said, the middle term plus 2 times 1/3 A times 2/3 B is going to give us, let's look at the entire problem now at the bottom here. So we have this term is the middle term. And here's the, oh, my pencil's going bad on me. I got to figure that out. Okay, so the middle term and the end term. So to get the math on the first term, 1/3 A squared, 1/3 squared is 1/9. 1 times 1 is 1, 3 times 3 is 9. And A squared, because we're going to square the A. Then on the end term, it's 4/9 because 2 squared is 4, 3 squared is 9, 4/9 B. 4/9 B. Right here's that. The inner term is right here, 2 times 1/3. We can do this easily, and it ends up being 2/3. So we have 2/3 A times 2/3 B. Well, what is it when you multiply 2/3 times 2/3? You get 4/9. And you get A and B. 4/9 AB. This is exactly like that, what we had before. You have an A term with like the DD, and you have the YY here for the B's, like YY, and then you have some combination of D's and Y's in the middle term, right? So looking at this, it says, let's go to B. We've written out the equation now, so let's go to B. What is the probability that both number cubes will roll a 1 or a 2? What's the probability that you're going to get a A roll, a capital A roll. Well, the probability you're going to get a capital A roll is going to be 1/9. 1 in 9 rolls will both cubes have a 1 or a 2 on them. Don't have to be the same number. They have to be an A roll, a 1 or a 2. 1 in 9 times. Okay, so 1/9. There's the answer. How about C? What is the probability of one number cube showing a 1 or a 2 and the other number cube showing a 3, 4, 5, or 6? That's the middle problem, the middle section, right? Where you have an A and a B simultaneously. And what are the odds of getting an A and a B simultaneously on those cubes? It's 4/9 is the probability here. The number they tell you right here, it's 4/9. And so here, 4/9. And this is what's the probability that both number cubes will have a B roll on them, 3, 4, 5, or a 6. Well, the answer there is you go to the probability of the B roll, the BB, both having B's, it's 4/9. So 1/9 of getting an A roll on both dice or cubes. 4/9 probability of getting an A roll and a B roll both showing up. And 4/9 of getting 2 B rolls. I hope that makes sense. I looked at it and thought about it for a while. I hope you can see it. If not, make a comment on the video, ask your question. We'll go over it again. I'll make another video if I have to try to help figure this out, okay? Okay, example 3, mental math. Find 51 squared using mental math. So 51 squared, we're going to break that into a binomial squared. And we're going to break it into 50 plus 1. Right here, 50 plus 1 squared. And since we could do that, we can now say 50 squared. Take the first term and square it. We can take the last term and square it. We get 1. 1 squared is 1. And the middle term, since we have a plus here, we have 2 times 50 times 1, which is 100. So the answer is 2,500. 50 squared is 2,500. 2 times 50 is 100 times 1 is 100 plus 1. 2,500 plus 100 plus 1 is 2,601. Let's try 49 squared using mental math. 49 squared, we're going to convert that to 50 minus 1. Okay, and we're going to square it. So 50 squared is 2,500. 1 squared is 1. And 2 times 50 times 1 is 100. Is 200. No, it's late. 100, and it's a negative. So it's 2,500 minus 100 plus 1 is 2,400. Okay? Sorry, that little hiccup there in my brain. So checking your understanding. So you're going to go off and do these on your own. They shouldn't be too difficult. Go ahead and try them. When you come back, we'll work them together. Okay? Okay, now I'm sure you've had the time to do them, so let's do them together. So problem A, 31 squared is 30 plus 1 squared. We broke that down to 30 plus 1 squared. And in doing so, I can get 30 squared. I can square the last term, get 1 squared. And 2 times 30 times 1 is 2 times 30 times 1 is 60. So 900. 30 squared is 900. Plus 60 plus 1 is 961. Let's do B. 29 squared is 30 minus 1 squared. So we'll get the 30 squared right here. We're going to get the 1 squared at the end. And the negative, we're going to have a negative 2, because it's a negative here. Negative 2 times 30 times 1. 30 times 1. 2 times 30 is negative 60 plus 1. So it's 841. And then over here, C, 98 squared is 100 minus 2 squared. 100 minus 2 is 98 squared. So the first term squared is 100 squared. The last term squared is 2 squared. And the term in the middle is negative 2 times the first times the last. Okay? 2 times 100 times 2 is 400. Negative 400 plus 4. 2 squared, 4, is 9604. 10,000. 100 squared is 10,000. Forgot to say that. 10,000 minus 4 is 9,600. Plus 4 is 9,604. So let's do D. Now we're at 203. So we're going to break that into a 200 plus 3 squared. First term, 200 squared, which is 40,000. The last term, 3 squared, which is 9. And this middle term, 2, it's a positive 2. Positive 2. 2 times 200 is the first, times 3 is the last. 200 times 3 is 600, times 2 is 1,200. 40,000 plus 1,200 plus 9 is 41,209. Okay, objective 2, the difference of squares. It's a new thought for us here. The product of the sum and the difference of the same two terms also produces a pattern. So if you say a plus b times a minus b, that's the sum of the product and the difference, right? The sum and the difference. And that equals a squared right here. We're going to square this is using FOIL, right? Square the first terms, then it's minus b times, minus plus b times a. There's plus b times a here, and then because I was going for the wrong term, and then in the inner, it's our outer is a times minus b, a times minus b right here. First, a squared. Outer a times negative b is a negative ab. Then inner is positive ba. Here's your positive ba. And finally b squared, and it's negative b squared. Okay? And what you'll notice here is that these two terms disappear. They cancel each other out. And you're left with a squared minus b squared. So this sum of this, the differences here, the difference of squares, a plus b times a minus b, gives you a squared minus b squared. And note here, it says, note that the minus ab and the positive ab equals 0. So it leaves us with the a squared minus b squared. This is called the difference of squares. And there's a rule here that we can follow right here. Here's the rule. If you have a plus b times a minus b, the answer is going to be a squared minus b squared. And the product of the sum and difference, it's a product, here's the product, the multiplication of these two, of the sum and the difference of two terms, of the same two terms, is the difference of squares. Difference of their squares. Example 4, finding the difference of squares. So here's an example for us. T cubed minus 6 times t cubed plus 6. The difference of two squares. So we rewrote the problem, t cubed minus 6, t cubed plus 6, and I get, with parentheses here, t cubed squared minus 6 squared. So finding the difference of squares. And then I'm going to carry out the math to simplify. T cubed squared is t to the 6th minus 6 squared, 36. Okay? Okay, so now, example 4, check your understanding. Find each product. Well, you're going to go out, these are the same as we've been doing. So the product of two squares, or no, the difference of squares. And we're going to go ahead and work them on our own. And when you come back, we'll work them together. Okay? Good. Okay, example 4, check your understanding. You're back. Okay, we're going to go ahead and try and work on it. It says find each product. So if we look at this, we have, in problem A, we have d plus 11 times d minus 11. So this is those difference of squares, right? And we see the first, when we write it down to begin with, right here, always repeat the problem, And we take the first term, d in this case, and square it. I always put parentheses around the term because it's not always going to be a single character or a letter or a variable. In fact, I think when you get down here, look at down here, 9v cubed. So it's more than just a single element in here. So the quantity d squared minus the quantity 11 squared. Well, d squared is d squared minus 11 is minus 121. There's the solution to that problem. How about b? C squared plus 8 times c squared minus 8. Okay, so we take, here I've rewritten the problem, and I say c, parentheses, c squared squared minus 8 squared. And that gives us c squared squared is c to the fourth minus 64. 8 squared is 64. How about for c? 9v cubed plus w to the fourth power times 9v cubed minus w to the fourth power. Rewriting the problem, like we said, always rewrite it. And then put parentheses around the terms. 9v cubed with the paren squared minus w to the fourth squared with the parentheses. And when you do that, you realize, oh yeah, I've got to multiply the 9. I got to square the 9, 81. And then v cubed squared is v to the sixth because you multiply exponents to the powered exponents. And minus w to the eighth power. W to the fourth squared as w to the eighth. Okay. Okay, example 5, mental math. They want us to do a little mental math like we had done earlier. This time we're going to find 82 times 78. How are we going to do that? Well, we're going to break it like we did before. We're going to take and get these are the difference of squares at this point. So let's look how it works. We're going to take the 80 plus 2, which is the 82, and 80 minus 2, which is the 78. And we're going to treat it like the sum, like the difference of two squares. So we have 80 squared, and we have 2 squared, negative 2 squared here. And when we do that, we have 80 squared is 6,400, minus 2 squared is 4. So 6,400 minus 4 is 6,396. Case closed. Done. Pretty easy, huh? Okay, we're going to, example 5, check your understanding. You know what to do. You do these on your own and come back. But before you go, I want to mention something that I didn't mention in the previous slide, that when you're doing these problems, if you notice that this is 18 and 22, right? So they surround the 20 term. And they can give you so that it's the same up and the same down. So I can take the 18 to 20, and it's going to be minus 2. And I can take the 22 to 20 and add plus 2. So you get the minus, you get 20 minus and the 20 plus, the same number. So you get that picture? So when you're doing it, so then here the 19 is going to go to 20. 19 and 21 goes to 20. 59 is 60 and 61, right? 87 and 93. It's the 90s that we're going 90 plus and 90 minus. Anyways, when you do that, just think about that. And when you get back, we'll do them together. Okay, so now that you're back, let's try it. So we have problem A. 18 times 22 is, we're going to rewrite that as 20 minus 2 for the 18 and 20 plus 2 for the 22. And then we have a first and a last term, and they're identical except for the negative or the positive sign, right? It's the same difference of two squares. So we have 20 squared, which is 400, minus 2 squared, which is minus 4. 400 minus 4 is 396. 19 and 21. So that's going to be what? That's going to be 20 and for both of them. So it's going to be 20 minus 1 and 20 plus 1. Right here. And if we take the first term and the last term, we get a 20 squared, and it's minus, because we have the minus in here. Okay, so it's minus 1 squared, the last term. So it's 20 squared is 400, and 1 minus 1 squared is 1, so minus 1, which is 399. How about 59 and 61? So those are going to go to 60 minus 1 and 60 plus 1 for problem C here. And then we'll take the 60 squared is 3,600. And the 1 squared is 1, and it's negative 1, so 3599. And how about D? We're going to go with 87 and 93, so it's 90 minus 3 for the 87, and 90 plus 3 for the 93. So we're going to now have the first term and the last term. They're the same. We made them all identical. 90 squared is 8100, minus 3 squared is minus 9. 8100 minus 9 is 8091.